Okay, let's do this. So we have a die rotor design all lined up. And just while we're waiting for people to come in, we just got started here. We just got going. What's up, Jacob? Yes, Toga for comfort. Welcome to the stream. 4J4Y official. Hi. So we got all of our parts ready to go here. Check that out. So, yeah, we're going to get this thing going today. Oh, nice, Tanner. Let's go. I was trying to get it all scheduled, but honestly, I just couldn't figure out my schedule today. So, just is what it is. Yeah, I wanted this piece to be just like easy to see what's going on. So that's why we got red here. Okay, so I'm gonna be jumping back a little bit from my computer to my table. What's up, Prash? Prash makes. Yo, how you doing? I just got to get used to. I have a camera here, but my computer is over here. So if I'm looking here, if I'm looking right here, it's because I'm looking at the chat over there. But work with me, guys. Work with me. This is all new to me. All right, so I got to figure out, first things first, I have to find the bearing that's going to go in here. And I don't know where it is. Maybe it's under the desk. Hold on a sec, guys. Got it. Got it. And it's not a huge bearing. The box just contains something else. It's bigger, so. Yeah. Let's see what we got here. Oh. Look at this. Ooh. That's overkill right there. But we needed a big bearing because this is supposed to go in here, which it fits beautifully. And then a ball the size of a ping pong ball has to be able to go through it. And so that's why I went with such a big bearing here. But ooh, that's nice. All right, so I guess we're probably gonna just start by stacking. I guess we gotta get the bearing first. Just gotta press into here. Let's just see if we're in a good spot. Yeah. And if I'm missing the chat a little bit, guys, it's because I'm gonna be like just trying to get the build done. But I'm gonna try to also remember the chat. Maybe I'll move it up here so I can see it better. All right. So let's just see if this is gonna fit. It should fit. I just don't know the best way to get it in there. It's just kind of big for, I can't put it in the auger press, but yeah. Okay. Go with the old human press. Go with the old mallet. Okay. All right. That's pretty good. Clean. Mallets away. All right, don't break it. Don't break it. I know. Sometimes you gotta do what you gotta do, you know? Okay, I'm trying to remember how this all goes together. So I'm gonna pull open the CAD and we can see what we gotta do first here. And it looks like first things first, we have to, I think, assemble, just wanna see, hopefully I didn't forget something or mess something. I think we gotta assemble this whole thing. So this is what we're gonna assemble first. So let's do it. And yeah, we should be, I think I forgot one thing here, which is I'm supposed to have screws coming down through this piece into this piece, and the screws are gonna interfere with this guy. And it's just like silly mistakes, but there's a solution to all of it. And I'm gonna show you what that is. So that's this piece right here is supposed to screw down into this guy. And I forgot to make very simple counter bore holes in this thing. So, yeah. Thanks, Prash. Engineezy live. Oh, it's not on this screen. What can you do? I'm really gonna try to keep an eye on these comments, guys. But if I'm missing something, just yell at me, okay? But first things first, we gotta counter bore this piece. So that can go there. And then I have this bearing that goes in here. Can you see what I'm doing? No. Boom. So this bearing goes in here, and then this guy goes here. Boom, like that. And then this spacer, and then this guy. And maybe I can get away with, I have these like flathead screws. Let me grab them. These right here. So see how they're like very low profile head? Come on, focus. Right there. So that might be able to clear. If not, we'll have to counter bore. Oh, and I forgot to, guys, I was missing a lot of things yesterday. Where's my drill? Got the drill. Need my drill bits. But remember, you can always make a hole bigger. So having a too small of a hole is not really that big of a problem. Just gonna drill out these holes here. I've definitely seen a few of those die rotors. But they're a little bit different actually than this one. Those ones have like a wheel. I think the die rotor part's kind of the same, but then they have like a wheel that like shoots them out of the thing. So it's like a die rotor combined with like a ball launcher. But very similar principle, I think, in the end. And Prash, I do love a low profile screw as well. Let's see if that's there, and this, it'd be a spacer. It's the same size on both sides. And that's there. Does that clear? Oh, yeah, it does. I don't know if you can see. Oh, you can't. It's really hard to see. But we're good. So sometimes problems solve themselves. Okay, so we got to put this guy onto this guy. And I'm using this electric screwdriver because it's bomb. It's got a built-in clutch. And even still, you might strip threads, but. Now the other question is this directional? It might be, it might not be. Let's take a look at the CAD. I'm gonna try to live stream as much as possible. Okay, I just want to make sure that this didn't line up perfectly, which it doesn't. So we're good. Back to this view. And I'm stripping the threads. But it doesn't, you know, the nice thing about using these M screws is like, if you accidentally strip it, it kind of just melts and then like reforms. So it's fine. Also for this build, it really doesn't matter if it strips a little bit. Okay, sick. So that goes like that. Then this will go here, like this. And then this goes here. And then now we can use these screws that don't really strip. And they go in from this side. I'm using mainly PLA Plus from eSun. I've been using it for a long time. It's always done me really well. And this is not sponsored. I've actually like reached out to them for sponsorship, but then they never really got back to me, and then I kind of just gave up. But I've been using it for like, honestly, like 5 years or so, maybe more. And it's really good. Like it's like low friction. It's strong. It kind of like it drills nicely, and I don't know. It just gets the job done. What am I trying to do? This goes here. This goes here. And then it goes through this guy. Nice. And then that screws into this guy. The reason I like this screwdriver is it's got this clutch. That means you don't always often strip threads. And what do we jam it? Oh yeah, we're good. But I forgot that there's 2 screws here, and I tightened it down a little too much. Where is the other hole? There. This is, there's no target balls per second. This is purely kind of just like an exploration. Because I was curious. Let's see if that works. Oh, that's so nice. I was just curious if this was like, I don't know, just like how much faster it's going to be, like what the difference is going to be from the other version. The other version's already fast enough, I think, for the thing that I'm trying to build, which is like a big ping pong ball gate system. But yeah. Can you set the torque? You can, like, there's just torque settings. Like, there's like max, and then there's 1, 2, 3, 4, 5, 6, 7. So there's 8 different torque settings on this thing. I was originally using a Dremel one, which Bosch and Dremel are the same company, so I don't know. They're kind of the same, but the Dremel one got confiscated at the airport, which I was so upset about. And then they stopped selling it. But also it has USB micro, and this one has USB-C. So I don't know, Prash, we were just talking about that recently, but yeah, I was tired of like having those USB micro cables kicking around, or whatever they were called. Yeah, I know. Bit the bullet though. This one's a little bit nicer. It's got a nicer clutch. It's got this like locking bit thing, which is sometimes good and sometimes bad, but yeah, for the most part, this thing gets the job done. And it's good for like these like little assemblies that I'm always working on. Like a drill would be a little bit overkill for this kind of stuff. Okay, that's super nice. That's why I love using bearings. Look at how nice that is. I mean, we don't need bearings. Like I could probably just get away with having like 3D printed parts, just moving on 3D printed parts because it's pretty low friction, but you know what? Nothing to complain about here. Okay, I forgot these, that I didn't print enough of these, so I'll be right back. I just printed them. Oops. I kind of messed up, guys, and I printed them like this. And so they're not going to really, you know what, they might actually work fine like this because they're bigger than a ping pong ball, but if not, I'll just print new ones. That was a mistake. I had the settings set up like that because I've been working on something else that just I needed like a really, really quick prototype. But honestly, I think this might be fine. And it will push the balls, which is what we need to do. So kind of a happy accident, I guess. I do kind of a combo about like the parts in context and the, like sometimes I do it and I don't worry about it, and other times I don't. Yeah, sometimes I try to like make each part individual. I still haven't decided on which way is better, like what the best practices are, but do I ever use the desk cleaning robot? No, I do not. I never finished it. Like the first video just like didn't do that well, and I was like kind of bored of it, and so I decided to just like let it go. Maybe one day I'll come back to it. We'll see. I kind of want to just make it like a big, like painting robot or something. Like paint like massive something right across the workbench, or I don't know. Maybe make it like set up like a huge domino run or something like that. I don't know yet. I haven't decided, but yeah. How many 3D printers do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have about 11, but one's in a box still, and one's high up on a shelf that I don't use. Even though I would use it, I just have been too lazy to get it down off the shelf. So yeah, 11. It's a good amount. All right, let's keep going. So next thing I need to do is basically get this whole sandwich stack. How does this go? Like this. So we got, oh, it goes like this. So we got, this goes here. This goes here. I have to drill this out. I think I forgot to make the holes bigger. And I think I might need to get different screws for this, but, oh, do I have to drill this guy out too? Oh, so annoying. It's like so annoying because this is just like a simple command in SolidWorks, and I just forgot to do it. And now, I mean, let's be realistic. This is not so annoying. I mean, it's taken like 30 seconds to drill out all these holes, but it could have just come off the printer already good to go. And that was my own fault. But yeah. I should do a collab with another YouTuber. Maybe I will. I agree. One day I will. Okay, I guess gotta get the other screws. They're right here. They might be too big, but if not, we have shorter ones. These are M3 screws, which, let's see if I can show you the difference. So these are the number 4 screws that I normally use. These are M3 screws. You can see there's a lot less threads on these coarse thread forming screws than these. These are kind of meant for forming threads into plastic. These aren't, but it works, and it works really, really well. I think one day I'll do like a project, I'll do a video showing like, I don't know, like how strong each of the threads are, because I'm curious. I've never tested it myself, but for now, I just want you to know that they work, and they work well. So let's do this. So this goes in here, like that. And then this goes in here, like that. And then this goes in here, through there. Perfect. And then this is going to thread into the bottom of this guy. And this is going to be a bit tricky to get it, but not too tricky. I think I'll put another one in just to keep it from squiggling. There we go. And I got to turn down the torque setting, I think, on this. See if I can get this. Sometimes it's easier to do this manually. It's hard to see. I can actually see this one better. Get in. Torque setting is too low. Hey! Okay, and then this one. Nice. Very nice. So look, you can see that that will rotate this way like this, and then this will rotate that way. And so far it looks like my design is going to work out, which is good. Some minor inconvenient things I gotta change. That screw is the wrong size. Got mixed in with the bigger sizes. Okay, now we can tighten it all down. I actually have the wrong bit in the screwdriver right now. I'm too lazy to get the bigger one. I'm just gonna get it. What would you guys like to see? Who would you like to see a collab with? I want to do one with Ivan. Do you guys all know Ivan Miranda? He's the guy. And you can hear that clicking sound. That's the torque. That's the clutch. It's just perfect. Okay, so look at that. Boom. So we have our gear underneath, this on top. Beautiful. That's just so nice. And you can see it from this angle. That turns. So nice. Professor Boots. That'd be sick. Zach from Voidstar. I didn't do anything with a Zach from Voidstar. Prash. Also, maybe one day I'll collaborate with this guy called Prash Makes. That would also be pretty awesome. Prash and I kind of did collaborate on an idea, which will be coming soon. At the very least, he inspired me to go for it. But I'm not going to give it away. Oh, I was actually planning to put these in, these paddles. I guess we can put them in now. I'll just use this screwdriver. And I think that I made these holes too small again. Or maybe they're a different size. Let's see. Do this guy. Open this. Let's see. No, I did make them the right size. Oh, because these are 2. Okay, we got to get the other screws. These are number 2 screws, a little bit smaller. Boom. It took, this was like, all of this was printed in like 3 hours over 4 printers. So the thing that took the longest was this outside shell. I think it was a 3-hour print, and then everything was shorter than that. Let's screw this in. Nice. And you know what? Why don't we throw a ping pong ball in here just to see if this is going to work? Because if it's not, it's better that we know now before we assemble the entire thing, right? So, turns out I have a ping pong ball right here. So, the paddle should hit it. Yeah. And then I think it's dependent on more, but oh, sick. That's really, really simple and smooth. So if I just hold this straight. This has to go this way. Yeah, nice. So it works. I mean, at least the dimensions work. And I feel like it's going to be pretty fast when we actually start getting it cooking. But one thing I did mess up here was this. There's a gap here. But it might be fine. We'll chuck a couple more ping pongs in there and see what happens. It would be an armor. Oh, styropyro. That'd be crazy too. Let's just see what happens. We have a bunch of these in here. Oh, guys, we are going to be absolutely cooking with this thing. Okay, sick. I'm like very, very confident now in this design. It's going to work. Might need some optimizing, but it's going to work. Crazy how, guys, subscribers mean nothing on YouTube, just for the record. Especially on like live streams like this. You know, you can't just start up a live stream and expect all 1 million of your subscribers to show up. But okay, let's keep going. So I think I need a motor, and I have some right here, I believe. Oh my God, 3 ads. Apologies for that. What's my favorite video? Like, what's my favorite like video that I made, or just on YouTube in general? My favorite video on YouTube is Ivan Miranda's Marble Clock. Honestly, that whole series is phenomenal. He's just such a madman. It does work. It works very well. I've been buying these stepper motors like one at a time, and so I finally just decided to bite the bullet and just buy a multi-pack because I knew I was going to eventually use them. Boom. So sick. Look at that. Oh, that's such a thrill for someone like me. We could definitely try flipping the paddles, but they might get in the way of the actual like thing. I didn't really optimize it. Like I kind of just, I don't know. I just came up with like a very simple version. Yes, Prash, these are NEMA 17s. And I just like that they have this like DuPont connector on the end. Okay, so this guy is gonna go in here. Let's see, we might be able to use these, but I might need shorter ones. So one nice thing about NEMA 17s is we have M3 screws, which I need to get shorter ones. I'll be right back. I don't know which size I need, maybe 25s. Generally speaking, my printer settings are like pretty much stock standard. I use a 0.4 millimeter nozzle. I often just do 2 outside lines, like 15 to 20 millimeter infill, like nothing crazy. And then I design everything off of that. So everything, like all wall thicknesses are often like a multiple of 0.4. So like 1.2, 1.6, 2 sometimes. Yeah, that's kind of my go-to with that. It's crazy how quickly I make a mess of my shop. I just cleaned it. And like all these drawers are back out. I really do need to get my shop bot actually properly working. So it'll make my life easier. Okay, let's get this motor mounted. And that's gonna go on here. And I think I need these guys. Boom. And then I have these spacers. Boom. And that's probably too long. Okay, I think I need these guys. Sick. How are the balls going to be fed into the hopper? I don't know. They're going to find their way in. Nope, these are too short, so I got to use the 20. Oh, that was in the wrong spot again. That should be enough thread to go into the motor. So you can see it right there. Yeah. So dealing with spacers is kind of a pain, but it was the easiest way to make this work. And so we're just going to do it. There's one. Get a spacer in there. Nice. Get a screw in there. Perfect. And I think I'm only going to put 2 screws because that's perfectly fine. There's not a lot of force, I think, that's going to be on this. Okay, now I need a coupler, which hopefully I have one. I should have one. There it is. And this, and look at that. Even more tools coming out. Well, I'm glad that you're here, a Lego minifigure. I appreciate it. I appreciate you watching. I appreciate all you guys watching. It's nice to get to do this. It's like a lot more casual. We get to just like have fun building stuff. This is the coupler, by the way. This goes on here, and I think I'm gonna grab some other screws because these are gonna be too long. Be right back again. Okay, there we go. Yeah, so these couplers are really nice because it allows me to set screw with a metal screw onto the motor shaft. And that way you can crank down pretty hard and it's never really an issue. Now, what did I do with, oh, it's here. So what I've like found in the past is I've used like these types of screws directly. Like I would basically like print this coupler coming out, and then I would screw like regular screws as set screws, and then they would just end up stripping. So that's why I've like defaulted to this. But it's really nice because that just goes like that, and then that just goes right here onto the shaft of the motor. And if I can get these set screws right, just like that. And what are we getting stuck on? Oh, I screwed that up too. Oh my God. Guys, I made so many mistakes on this. Crazy. But it's all good. It's all good. That's why it's so easy to make a hole bigger, way harder to make the hole smaller. Okay, now that will slide on just like that. Perfect. Okay, and then what's next? This is gonna go on here, just like that. And we're gonna screw through here, and oh, look at that. I actually, for once, made the hole the right size. Maybe it's all scripted, Prash. You guys are you're putting the conspiracy thoughts into everyone's heads here. It's possible that it's scripted. That's why the jokes are just landing so hard, right? Okay, sick. And just to test that. Oh, nice, nice. Okay, that should be good. All right, I think, oh, before I do anything else, I have one more bearing to chuck in here. Nice. Okay, now we can screw this on as long as these holes are the right size, which I forgot to make those holes bigger too. My goodness, guys. Let me show you what I should have done so you understand why I'm so annoyed. So in here, all I had to do was on, which part is it? On this part right here, on these holes right here, all I had to do was this. So simple. I go move face. And just had to click all this. 1, 2, 3, 4, 5. Go 0.3. Boom. And now it would be in the right size. Just like that. Yeah. So that's how you know this isn't scripted. Otherwise, I would have gotten that right. Okay, let's keep going. I'm just going to drill out those holes quickly. Okay, sick. And actually, there's one more thing I want to do, which is basically I need to attach this here. This is just the aluminum extrusion that I'm always using to just build quick structures. And so I'm going to use that to mount this. So I just need a couple pieces for that. So these extrusions, you can get these, basically these nuts just pop in like this, boom. And I'll do the other one as well. And then you can screw right into those and it locks like really tight, really nicely. And then you can like slide it into the right position. And then I'm just going to put the screw in and we'll slide it into the exact right spot. Then we'll tighten it down. Made it too tight. So we'll try to center that like that. It's good. And just tighten it down really hard. And boom, now we have a little mounting thing. I didn't make it exactly centered, but yeah, let's just make it centered while we're here. Oh, because once it's attached, it's harder to fix. Yeah, that looks pretty good. I'm not using the big walled robot because it just doesn't work that well. And I don't feel like making it work better. Yeah, this is just 2020 V-slot. So for anyone who sees this, it's called V-slot because these slots, I guess, are sort of V-shaped. And it's 20 millimeters by 20 millimeters. And then you can get this in like 20 by 40. It comes in 20 by 60, 20 by 80, or you can get 40 by 40. And basically you can build anything. This is like Lego for adults, which is so sick. Okay, I just want to make sure that I don't miss anything else. I think that it's time to put this on here. And I think, so you'll see now, oh, so one thing is I gotta make sure that this is on the motor, I guess, first, but I don't know exactly where I want it to go. We can adjust it after. So this just goes onto here like this. And sick. And we can tighten that down after. Let's just screw this in and then we can tighten it. So I'm gonna use these guys. You can go drop one into each of them. 1, 2, oh no. Oh no, oh no. I'm losing screws. Boom. 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 Now we can hit it with this guy. Sick. Now we gotta just get this gear locked into place. And it should be fine. It's a little bit tight in there, you can see, but it's good. Oh no, I brought it down too much. I accidentally just took away all my clearance there. A Lego minifigure. To answer your question, what do I do? Well, for example, behind me, the Flappy Bird project is still sitting there fully intact, but I need to break it down because it's just taking up so much space. A lot of the times like my dad is retired, he'll come in here and he'll take care of that for me. It's like easy for me to, but if you ever see like the wrong screws in the wrong drawers, it's probably because my dad was here making a mess of things. But I still appreciate it because otherwise I don't do it myself. Okay, look at that. So our motor is now mounted and that turns this thing. So the last thing we need to add now is the gear that comes up through here and turns this thing the other way. And I don't have it on my table for whatever reason. Here it is. Before YouTube, I worked for a toy company. So I was designing toys, or sometimes I was designing toys, but a lot of the time I was building prototypes for the for the designers in the company. So they would have an idea for a toy, they'd come to me, and I'd be like the person who helps them prove that it worked. Okay. So to attach this gear, I think we've made some good choices here for this. That goes in like that. Put a couple washers, and then that will come down and screw right into place, right there. How do I come up with ideas? I definitely consider engagement. It's an important part of what I do. But also I'm like kind of like always thinking about what I want to build next, you know? Like it's like coming up with ideas has never been a problem for me. I just always have more ideas than time to actually build things. I'm just gonna pop that on there first, just to make sure I'm doing everything straight. But this is actually, I'm like very happy with the way that I designed this. This is super nice. That goes there. The toy job was a dream job, except for this is even more of a dream job. Because this is, basically I get to do what I was doing for the toy company, but with like whatever I want to build. So when I was working at the toy company, I was building like, obviously what the company wanted me to build, which was cool. I mean, toys are fun. So, but this, I get to do whatever I want, which is really sick. Have I considered mentoring a local robotics team? I honestly, like, I didn't even really know about the whole world of FIRST Robotics, actually, to be honest with you. But I've thought about it more for sure lately. Okay, looks like I put too many washers in there. I think I only need one. So I'm gonna just see if I can get one off without losing the other one. Come on. Be cool, Jay. Be cool. Be cool. Yes. Yes. Okay, sick. So now I should be able to push this down. There we go. Yeah, that looks good. I'm gonna use this guy to just tighten it. More torque. Ouch. This is it's always fun gripping onto the side of a gear while trying to torque into them, but got it. There we go. Okay, final step in the process. A couple more steps, but this is the final big step, is attaching this gear right here. And yeah, that's gonna go. Just need a couple of these screws. There's one. Yeah. Hopefully I'm not making too many weird faces. Chief Delphi. Interesting. I'll take a look. I don't know if First Robotics just like didn't exist when I was in high school, or it just didn't exist where I went to high school, but I would have loved to have done that. That'd been sick. Okay, so the design's done, I think. If I do this, you can see now as I rotate from, oops. Okay, well, whatever, I'll just show you. As I rotate, you can see that one's rotating one way, one's rotating the other way, and it's actually gonna go this way. But the last thing I need to do is add these guys to here. I don't know if it matters if they're on the front or the back, but I was picturing them on the front, so we're just gonna stick with that. I obviously got the first one wrong. There's kind of a rule in engineering, in building like a prototype, is if there's like, if I could have put it on this side or I could have put it on this side, and this is the right side, I was gonna put it on the wrong side first. And it's kind of like a rule. Like 90% of the chance you end up with the wrong 50%. So if that happens to you, just know. It's just the law of engineering. Okay. I actually think these printed this way are gonna be completely fine. They might break, but if it breaks, we'll just print new ones. Fortunately, I put these holes in a position that is easy enough to get without having to take anything else apart. What's up, Brock? Have you ever thought about doing a project with Lego Technic? I have, but like Lego Technic is so expensive that like I just don't know if I would want to. I don't know. I can design like any part that I want. So having to use Lego would like, it'd be a restriction. I mean, sometimes that's a good thing. Sometimes having that constraint is a good thing, but I feel like there's like some channels out there already that are crushing like with what's possible with Lego. Like I saw a guy make a Lego typewriter, which was insane, crazy what he built. And I just don't know if it would take me a long time like messing around with Lego to get to a point where I'm like capable of knowing what's possible with Lego, if that makes sense. Like you got to learn the rules of the medium, and I just know the rules of this medium really, really well already. So that kind of answers that. Do I consider CNC milling? I do, but I used to do it quite a bit actually at the toy company, but it's a lot of work. It's tons of work, honestly. And like 99% of the time I can design for the tools I have. But it would be nice to get some metal parts sometimes. Prash, exactly. Everything's always right the first time. That's exactly what we did look at. That's where this design came from, was an automatic paintball feeder. But I appreciate the suggestion. Oh no. Oh no. Oh no. come on. Okay, nice. All right, the next thing we got to do is wire this baby up. And I'm just going to pull the electronics from the original one because it's kind of the same. I also got to maybe put this on a little stand. Should we build a stand for this thing? No, just put it right here on the table. Just see what I have as far as aluminum extrusions go. I'm going to take you to my stash. Okay, so I have a stash here, so I think we have more than enough. Really the problem is, do we have enough brackets? Which we might not. All we really need is like, that's probably tall enough, and then we need like, oh my, we're good, we're good. Let's just see. Just gonna bring it all and we'll figure it out. And then as far as brackets go, let's see what we got. I have a drawer here. Aluminum extrusion brackets. And it looks like all of my corner brackets are gone. Use these. These are from the bubble machine project. So someone was asking what I do with this stuff from other projects. Often I will just stash it in here. I need some corners. The corners are what's going to be the most useful. Let's see. I might have a couple here. I have one here. I thought I had more. Oh, I do. No, those aren't corners. Bollocks, as they say. Huh. I can use these guys, I guess. These guys are a bit overkill, but just trying to make a simple stand, you know? And we'll grab these guys. See if I have any more in like one of these miscellaneous. No. 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 Oh well. We're just gonna make it work. And so I need some screws. Which guys are those? These guys here. Okay, and now I need, oh, here's the Dremel screwdriver, by the way. I had two of them. One of them got confiscated, and so I replaced it. And I think this is, yeah, okay. We got everything we need. Got this. Okay. And the other thing that we need is a little bit of water. What's up, Creationary 3D? Yeah, that Lego typewriter was insane. Yes, Brock, if I do anything with Lego, it's definitely going to be a GBC project, for sure. No question about that. Okay, so we basically just need one piece going this way. And these brackets are no good for that. These brackets are fine, but they give you a lot of like wiggle. These ones are the best ones because they have a lock. But I think I'm gonna use these guys. Excuse me for one. Oh, I already had my pocket here. Paul, well, this shop has been many, many years in the making, but I just love it so much. Just getting warm. All this running around my shop. Oh, enjoy your lunch. I could go for a second lunch right now, honestly. Starving. Always so hungry. Okay. Boom. Okay, let's do this. So, I'm going to drop a couple of these in here. 1, 2. That's going to go there. And there. Okay, now we need the longest one we have is this guy. This is gonna go here like this. Let's drop a couple in here. By the way, these are like the best ones that I found. See, they have this little, oh, that one's actually missing the ball. They have this little ball in them, just like that. And that allows it to like stay in place, which is nice. The alternative is ones that don't have the ball, which, where did I just drop that one? If they don't have the ball, they just slide around and you have to screw them into place. These I just find a little bit easier to, like, you can position them before you have to like screw anything into place. Just like this. Nice. Get a screw in there. I can move this guy up into place just like that. Drop a screw in there. How do you guys feel about this view, by the way? Should I drop this camera down a little bit, like bring it a little bit closer like this? Ooh, that does look nicer. Okay, sick. Okay, now we got that. We got to put a stand on the bottom. I got way too, these are too big. Hold on. Let's see. Just kind of want to make a triangular stand here. Like that, like that. Let's see if this works. So this guy would go, it's not great. I need a slightly smaller one. I'll be right back. I think I have in this box. Perfect. Okay, I think I got what we need now. So we're gonna drop this onto here. This one came already with these guys in it, which is amazing. Boom. There's no target speed. We're just trying to see how fast. Basically, the target speed is the max motor speed. That's what I'm going for here. Kybotics, I appreciate that. Thank you so much. Thanks for watching. Happy that you're able to grab some value from what I do. It's just like the best thing ever. I get to do, just have fun building stuff, and it's like nice to be able to share it with people who actually appreciate it. I gotta zoom up a little bit so you guys see the whole shebang of what I'm doing here. Slide this into place just like that. This is exciting. I'm like very excited to see this thing working. The electronics are kind of already ready to go. So it's just building this like final little stand for it. So it can actually stand up. Just got to make some legs now, and then we're good to go. So the legs are just going to be like these guys right here, like this. Paul, well, I'm honestly like a little bit shocked that I'm capable of doing this, but you know, there's a reason why I made so many mistakes on the last design, but it is what it is. You know, it's worth it. It's worth just so I can chat with you guys. I can definitely do the building part and chatting part. It's hard to do the CAD, like the engineering thinking part and chatting part. Okay. Get this in here. Get this here. Now we gotta cut a couple on this guy. I want you to be able to see what I'm doing. So that's gonna go here like this. So I need to put a couple in here. One. I think we found the one that's missing the ball. Yeah. Kybotics, I'm happy that I'm able to get you motivated. I just want everyone to know, like, I don't know, just like a little, like, when I work on new projects, I often don't know what I'm doing. And I'm like kind of figuring it out as I go. I mean, now I've done a lot of projects, but there's certain projects, like, if you saw the video where I built the golf simulator, like that was like one of those projects. I was like, this is scary AF. Because I had never built anything that big before and wasn't really sure, you know, like what I had to like consider when I was working at that kind of size and scale. And honestly, like safety levels even. But you kind of just like work through each problem, not, you know, like take one step at a time. And often you find yourself finding a solutions to the different problems that you have. And like, yeah, I mean, what I'm trying to say is like, if a project's scaring you and that's the reason you're not going for it, you kind of just got to bite that and go for it. And then you'll learn as you go. My 3D printers make forbidden spaghetti all the time. So I'm with you on that. I will say though, often when a printer makes forbidden spaghetti, nowadays, because they've just gotten so good, it's either because I'm trying something I'm not sure is gonna work, or I forgot something in a design, or like I like positioned a part wrong and just can't deliver the entire thing. Okay, that's good. Let's just tighten everything down now. All right, aluminum extrusion for the win. Come on. There we go. All right. So the final thing we got to do now is basically just hook up the electronics, which I'm going to pull off of the previous version of this. I'm just going to reconfigure things a little bit just so I can set up the camera better. Let's see. I don't really know the best way to set up the camera here, so just work with me for a sec, guys. Funding is definitely a problem. I hear that for like most of my, like, you know, like the last 4 years, 5 years, funding was always a problem on my projects too. But you kind of got to just start You got to start where you can, right? With the stuff that you got, and then work your way up, piece by piece. Like this shop here, it took me a very long time to get to this point. Like it didn't happen overnight. I just want everyone to know that. Like I started in my parents' basement and just like slowly acquired all of this crap and moved to an apartment in Toronto and then the basement of my house, and now I'm here. It just took a lot of time to get here. So you just gotta be patient, work your way up, and you'll get there. Okay, electronics. Here we go. Got the electronics. Basically, we just have to hook up the stepper, and then we got to hook up. This is the brake beam sensor that measures the speed. And let's see if I got these even. Made them a little too small, these holes. I'm going to drill them out a little bit. And let's just see what size they need to be. So they are approximately 4.78. So let's grab 4.8. That's gonna be the one that we need. How do I make money? That is not a question I can 100% answer for you. With patience and hard work, that's how. Okay, sick. So we just got to put one of these on one side like this. And then one in the other side like this. And just make sure that it's not impeding a ball, which it's not. It's good. All right. So the final step, hold on one second. Let me just make sure we're all good here. Okay, I'm just gonna get my the controller open. Huh. Oh yeah. I forgot. The controller's running on my other computer, so I gotta plug it in. Boom. Good thing we have these long USB cables. Oh, it did fall out. Yeah, hot glue is ready to go, actually. That was my plan originally. So we're gonna get that going. Okay, boom. Just wanna make sure I can get this open first. Bear with me for a second, because I don't remember exactly what the IP address is. Okay. Let's see. Tools, port, this one. 192.168. Why is not working? Huh. What Master Sketches? Sometimes I use Master Sketches actually. Not often though. Not often. Sorry guys, I'm trying to get the like interface open that will show us the speed of this and allow us to control everything. If we can't get that open, we're just gonna use the old manual and we'll get a manual speed reading. But I want to try it for a little bit longer, just see if I can get it to work. I don't know if I have to like open, I don't know. Okay, let's just get the glue gun thing done. Hot glue for the win. Always. Put a little glue on this guy here. Okay, that should be good. I'll put one on the other side here too as well. Yeah, trying to debug code while chatting, that's hard part. And oh, also I'm gonna grab the hopper off the top of this thing. Okay, because we're probably gonna need this if we get this thing working properly. Okay, let's see. So it should be opening, and it's not. It says the address. Yeah, I don't know what the problem is here. It's like not really a code problem. I think that it's like a server problem. It's a good thing we have AI coding tools now though to help us. So it looks like everything here is right. I actually don't think we need this even anymore. And then we're gonna plug the motor into that, but brake beam is working. Nice. Yeah. Honestly, Paul, that might be the thing that we have to do. We're gonna figure this out. But everything else is ready to go. Get the box of ping pong balls. Ooh. And that's just gonna sit right here, quietly minding its own business. And now it's just the code is the problem. Oh, we're in. We're in. Everyone, we're in. Okay, let's just see if it works. So continuous run. Oh, I didn't plug the motor in. Haha. Okay, let's just do that. And you're not really supposed to plug a motor in while it's all plugged on, but okay. It is turning. The wheels are turning. We're going the wrong way. So one nice thing about stepper motors, if you're going the wrong way, you just flip the cable. And now we're going the right way. Okay, check it out. I'm trying to get you guys in a good spot. Okay, so it's running. We put in one ball. And nothing happens because I screwed up these paddles, but put in multiple balls, and now we start moving. Okay, let's just test the max speed here. So right now it's set to 800. Let's go to 1,000. And I got to turn on this power as well. Get more reliable power to the motor. Okay, I think we can go faster. This is 2,000. Let's see what happens. Oh, that's so sick. All right, can we go faster? 4,000. There might be a max speed set on the actual controller. Oh, it's doing a little bit of a... It's really hard to debug code under pressure, especially when you don't know what you're doing. All right, but that's pretty good. I don't know why we can't get more speed out of this right now. It's true. AI tools could be considered wisdom of the crowd. I think it's just easier to put them away manually and faster, way faster. Let's see. Okay, let's put this hopper on, and then we can like see what the throughput is of these balls. So, thank you. I appreciate you hanging out. Take it easy. Have a good evening. This is just gonna go on like here, maybe. Oh no. It looks like I accidentally changed the dimensions of the outside, which is why this isn't fitting exactly, but it's good enough. I should have checked this before I finished the design, but it will be fine. Okay, sick. All right, we're gonna turn this off. Pause it. Okay, let's dump all these balls in. And let's see if we can get this to work without jamming. I'm gonna reset the counter. And here we go. My coupler is... The coupler is not grabbing right now. That's too many balls. It's jamming. So let's try to diagnose why. see where the jam is happening. See what fundamental thing that I missed here. Now's where the real learning begins. Which one is causing the jam? Is it this guy? Or is that guy? Is it this guy? It's this right here. So the balls are getting caught. Let's see if we can figure that out. Let's see if we can figure that out. Okay. Let's take this off again. This could be a geometry, like I picked an arbitrary dimension for how I wanted to cut the like groove in the spiral thingy, whatever we want to call it, the rotor might be the best term for it. And it seems like, I think that this is just probably going to be fixed by solving the issue. So it seems like they're grabbing here, kind of like this. Like a ball is getting stuck here. It's just like a perfect space for a ball to get stuck. And the question really becomes, how do we fix that problem? Is it a paddle problem? It could be that we got to make the paddles flexible. It might be that we have to maybe get rid of the paddles altogether. Maybe we have to make sure, maybe we got to change the shape of this right here. Because when we have a single row, let's just put a single row in. There's a nice single row there. Yeah, there it is right there. Okay. Let's see if we can recreate that. Less spokes. I mean, it might, but there's always going to be a spot where things are going to grab, I think. You'll just have this jam happening on a different spoke, I think, is what would happen. So which guy is getting jammed? It's interesting, right there, do you see this? There's like this problem of it, the spacing being exactly right. If you can see the three of the balls. I'm gonna try removing the paddles first and see what we get. If we remove the paddles all together, I wanna see if it still jams the same way. The only problem is it may not scoop balls into the scoop very well, but it's interesting when you wonder. I wonder, like when like the die rotor was being designed, the original die rotor, like was that trial and error? Did they, could make them lower? I do think that no matter what we do with these paddles and this current geometry, there's always going to be a space where things jam. That's just my experience dealing with the packing problem of marbles or balls or anything. Which is, there's no escaping it really. unfortunately. But the thing is, you kind of need the top, I think, to agitate the balls, but maybe you don't. Maybe that was all just a pointless exercise in the end. And we can test that too. We can basically just like take out the gear and see if it's spinning or not spinning makes a difference. But what I think is going to happen without these paddles, is it's just going to keep rotating. And hopefully the balls from the top will push the balls down. But I can just keep doing that. And there it went in because it hit the paddle. I don't know. We'll see. We'll see what happens. The floor. That is definitely like more complicated than what I want to do. Let's just see what happens with this current setup. I'm just going to plug it back in. And we're going to run it. What's this about? Oh, continuous. Okay. So now we put in one ball. It's just going to keep going around and round and round. Put in a few more balls. Nothing's jamming, which is good. There's still a potential spot where it could jam, I think, like if a ball falls. Okay, so there. So when the ball gets between this top piece and this random, like miscellaneous. How do I recreate that? So what I actually think I should do, potentially, I think I should change the shape of this rotor. This arbitrary shape that I decided on is not helping us. It's going to be really sick when it's actually working and when I get the motor moving faster. But I think we kind of have to get back into, like, so basically the problem is, let's see if I can show you, is like right here, there's just like this perfect space for a ball to get jammed between the top piece and the bottom rotor. And if I come all the way out with this, I'll show you what I'm actually thinking in Sketch, because it might make more sense in Sketch. The Archimedes screw is a different design entirely, but that would be slower, I think. I think that's the problem with the Archimedes screw. That's what I used for my marble pixel display lift, was an Archimedes screw, but unless you have a really fast motor, I don't think you'll ever achieve the speed that this would achieve. So the top spinner technically exists to, like, I'm guessing to agitate the balls up top here and make sure that they're falling in. But also the paddles are stopping the balls from just being rotated around. Like this will just rotate the balls around and around and around until another ball pushes it in. And those paddles on these things were pushing the balls into the rotor. So what I'm thinking, let me draw it for you. So put this guy over here, bring this down. Okay. Let's see. What I'm thinking potentially, and I'm going to go back to the video as well and do a little bit more research, but maybe I leave this guy completely flat like this. And then on the rotor, rather than having like a paddle come, how do I draw? Rather than having a paddle coming down off the top rotor, maybe you just have like a, one idea is potentially to have like, sort of like a fork like that, that's sweeping through like potentially slots in this thing. And then that way it doesn't give us any spots for the balls to jam, hopefully. Another thing, I don't know, actually. I'm gonna have to spend some more time thinking about this. I'm gonna jump back over to here and we can just chat a little bit. A brush head, maybe a brush head. Maybe the inside curve of the spiral needs to be longer and straighter, but I don't think that that's the problem. It's the spokes. It's definitely the spokes. So I think that that's like the tricky part about the spokes. You have to get them in, like exactly right so it doesn't jam, but this is one of those things I'm just going to spend some time looking at and then come up with a solution, and then we're going to execute. Is it making the two balls squeeze each other? I think that part's okay, actually. Maybe not. I'll definitely take a look at that. Continuous jet of air, definitely that would work or help, but I don't want to mess with air. You need a compressor. It's loud. You have to mess with tubing and I don't know, valves and I don't know. Johnny, any advice if you're trying to start your own engineering YouTube channel? You gotta just start making videos. That's my only advice. Just start making stuff. I think I might try adding more spokes or changing the paddle design to be more exact. That's my guess. Paul Wall, let's see what you got. Lift the spiral padded up from the floor. So then you make the lines in the floor so the balls fall into the guide, balls into the center. I feel like it's just doing the same thing but in the other direction. No? Maybe not. Yeah, the rollers are also a different, it's a whole different thing. But the FRC robots don't seem to have they don't seem to have the top paddle system. Like maybe we just get rid of that entirely. I'll have to take a look and do a little bit more research. Yeah, maybe I'll just removing the spokes altogether. I wonder if I can do it from the inside here. It might be easier than I thought. Here. Because we can test it with no spokes. I just thought I'd have to take the whole thing apart, and I'm just kind of ready for a snack and call it a stream for today. But let's just do this before we call it a stream. Okay, I'm going to try to get the spokes out by unscrewing them from the inside. There's just no way for me to see. It's just 2 screw heads. We should be able to get them. Got one already. Sick. Where's the other one? Yeah, got it. Okay. Sick. Okay, break a problem down into its parts. Engineering 101, right? So let's see what happens if we just run this die rotor. no center, no spokes. Okay, plug back in everything. Boom. Run it. Turning the speed up. Oh. Okay, ready. Okay, interesting. Maybe we don't even need rotating spokes. The question is, once this is on, what happens? I'm just gonna tape it on for. Okay, should we just dump them all in? Should we do some at a time? Let's see. Okay, we're gonna do this. Here it goes. The curve is too sharp. I don't think that the curve actually is problematic here. It might be too sharp, but I don't know if that's the problem here. Let's see. Flexible fin, brush could work, a little flap maybe. So it's jamming again. Something fundamental that I'm missing. You can actually see exactly how they're jamming there. See right there? I'll stop it. You can see. So this right here is causing a jam of this ball. I gotta pull this off again. Oh, come on. So there's a fundamental geometry problem right here where this is causing a jam, where these balls are jamming in this exact position like this. And so I think that this is its own problem, because when we're hitting this position like this, they're getting stuck in there. Engineering is hard, but we'll figure it out again. We'll figure it out. Because it's like we're close. Now it's just like a little fine tuning. Trying to figure out, we got to be able to recreate that jam. I don't know how to recreate that right now. I'm gonna move this camera so you can see overhead here. This is definitely, it's a part. It could be the fun part. Got to keep a good attitude, you know? But yeah, it's definitely the fun part. Just trying to figure it out. Break it down step by step, and we will get to an answer. So when the balls are in this position right here, that's when it seems to be causing a jam. And I don't know if maybe we got to change the geometry of this. Maybe it is too steep, or maybe we have to make this whole thing smaller because there's just too much space. Maybe we'll have to reduce the spiral. I don't think we're going to do a redesign on this because we're going to, we already have a working hopper. So we're actually not trying to solve the hopper problem. We're just trying to test the die rotor specifically. So there, like that's how it's jamming. So like that's happening, that's going there. So we basically have to solve this problem where these three are lining up like this. And I'm thinking a very simple way to solve it. Since we already have our glue gun fired up, if I put something here, potentially that can break that angle. And I'm just going to try to use a piece of cardboard. Maybe this will help, maybe this won't. But if I put this piece of cardboard right here, maybe that will stop the problem from happening. Let's just try it and see. Nice thing about hot glue, I don't know if everyone knows this or not, but you can undo any hot glue with a little bit of rubbing alcohol. So it's the best like semi-permanent solution. Let's put this here. And maybe that will sweep things a little bit. Let's see. I've bought a lot of these marbles and ping pong balls from the internet. Smaller outside rim and smoother spiral. Yeah, definitely. We've seen a lot of ways of it jamming, but I think this way we're gonna solve one at a time, right? So now we can't get that 3-ball jam there. So that's good. Let's see if we solve that problem. And it still works, which is good. Just do a little bit of wire cable management here. Okay. So let's just throw this back on and just dump a bunch of balls in there and see what happens. Insta jam. No, that's good. That's working. Okay, one problem that I am having that I need to fix is the set screws on the motor are not they're not tight enough. So that's an easy fix. Okay. So what I want to see though is with that fin and this guy like here, is that going to solve the problems entirely? Let's see. We're just going to go for it. Guys, I think we got something here. A little compression at the side of the rotor to pulls the ping pong ball instead of relying on pushing. Yeah, maybe. But I mean, I think that we have something working here. I want to get this in position like here. Oops, sorry. So I think the key is that this is low enough that it's like right there. Okay, let's put something in place there. What's gone? It should, but I think that for now, like that's I think the point of the paddles on the that was the point of the paddles on the rotor that potentially is completely obsolete at this point. But what we really need is literally just a piece of cardboard glued on right here. So I'm just going to glue something on. Maybe I'll just double it up. It's got to be like here. Just going to use really simple. Let's see if my glue gun is still hot. It is not. So if this goes right here, so technically we want that to come out further. So maybe what I actually have to do is make this cut go further in actually. And that would solve the problem of that right there. Yeah, true. It could be that. We could add that too. Also, I don't really know about the curves. I think it could just be, I think the main thing that I'm gonna have to fix is the geometry of this cutout on the actual rotor itself. Because I think that's what's giving us the biggest problem. But I have some other ideas. Someone was mentioning about the floor having pins or something in it. No, I actually think we need to leave it open as it is. But if that goes right there, we should actually get some pretty good performance, I think. Let's just see if the glue gun's hot enough now. Let's drop that into place. I just gotta cut the bottom of it off. Okay. Look at that. So just this last guy, but I think I'm not gonna be able to fix that while this is currently the way it is. But let's dump the whole thing in and see what happens. Or at least a large portion. Okay, so first test with the new barrier system. There was a little bit of jamming there. I didn't really see what happened. Try it again. I will say, ping pong balls are a lot easier to corral than marbles. Okay. Turn it on again. Maybe I'll go a little slower. I mean, that being flexible is kind of helping. But there's a little bit of a jam happening. I'm not exactly sure where that's coming from. Oh, that's so satisfying though. Wow. The last ball, yeah, we can't really solve that problem at the moment, but we will be able to. So the inner cardboard is stopping a problem that I think is important for us to keep in mind, which is like that if 3 balls line up here, they jam in a straight line. And that's just breaking up that line. It really, this whole thing comes down to redesigning this rotor, which is coming. But yeah, the inner cardboard stopping this 3-way line from happening. The balls can't line up really. They sort of can still, but not the same to the same extent. But yeah, I think that I mean, for a first iteration, this really isn't bad. Like, this is actually like a very great place to be because it's kind of working. And I think that there is actually a very simple solution here, which just comes in figuring out basically like the geometry of the rotor. Where is it? Oh, we're here. And maybe what it would take is me just chucking some balls into the CAD model and like lining them up in different ways and just seeing what we can get and how we can get it to work better. But yeah, I think like for now, I mean, it's not bad. It's a good starting point. And I'm going to do a little bit of work, I think, off stream to get this sorted out. And then there's going to be a short form video coming out, like a short and like a reel and whatever. So stay tuned for that. And then I don't know if we're going to have another stream this week. Maybe we'll jump back on stream on Friday. Maybe we're going to do Mondays, Tuesdays, Fridays for stream. I don't know. I haven't decided yet. I'm still figuring that out. But yeah, thank you everyone for hanging out and helping me figure this out. And yeah, we're going to just keep moving. Does anyone have any like last questions for me before we call it a stream? Just hang out for a bit. Drink some water. Why am I making it? Okay, I can give you guys all the final little bit of context here. So, what I'm actually making is, where is it? Let me see if I can find this. I'm definitely looking forward to open source. There's going to be so many cool people there. Such a good time. Are you going to make it, Prash, to open source? I don't generally give out the files to my projects, mainly because I don't design them in a way that someone can really use them. And I just don't want to support them, if that makes sense. And like a lot of people, when they download the files, they like, if they're not like fully developed in a way that like works properly, and like they end up printing all the parts out and then I don't know how things go together and stuff, it just becomes a big headache for me. So that's the reason I don't often do it. But okay, for everyone's context, this is what I'm building, which is basically a binary gate system that can distribute balls into one of these 8 different lanes. And the reason why I needed a hopper at the top was to be able to distribute the balls into the thing. And I also wanted the hopper to be like controllable, so it didn't drop too many at once. Like I only wanted it dropping at one at a time. And so that's how we ended up here. And then the die rotor was just, I made a video about this and I was saying I was trying to get it as fast as possible. Exactly, Greg, like the marble one. And yeah, and so I was trying to get it as fast as possible. And then it's more than fast enough for this. I think that these gates are going to be the thing that slows down the whole system. But then someone mentioned the die rotor to me, and I'd never heard of it. And so I wanted to try designing one just to get a better feel and understanding for it. And like maybe I'll use this again one day. And we're learning. Like I made this an arbitrary shape, and now I'm realizing that was a mistake because obviously balls are getting stuck. So I'm also learning that maybe we didn't need this top rotor. But yeah, also it's just satisfying and cool. And I think it's going to make for a great video as well, which is also fun. So yeah, that's the context. That's why we're making it. But now it's kind of just about getting the die rotor to work, which we're almost there, which is cool. Trying something new, learning something new, exactly. Seisha, you might have to be designing yourself a ping pong ball launcher to help you train. The FRC community, I'm realizing I'm kind of right up that alley right now of FRC. Honestly, I would love to be like on an FRC team. I think that'd be so sick. Maybe I will do some FRC mentoring. We'll see. All right, everyone. I think that we're going to call it a stream here. And yeah, I'm going to do some work on this and hopefully have something to show in the next couple of days in the form of a video. Stay tuned for that, and then we'll get on stream again soon. All right, everyone. Have a good one. I use Baby Lab printers mostly, and then I have Prusa printers as well. And they all get the job done. But honestly, there's a lot of printers out there that are really good right now. So if anyone's looking for a printer, I would just do your research and see what you like. All right, everyone. Have a great evening, and I will see you next time. Peace out. Oh. Peace out.